Alright, welcome back generals to another Let's Fix Generals 0 hour to make the best game ever. Last video we have worked on implementing ASM matcher. We made good progress there. It can now compare already the instructions left and right. But there is some more stuff we want to do. But before we get to that, there has been some questions here by Psychana. So he's working already on reading data from the Mac-O file to get information about pristine 0-hour symbols. And he has questions how to organize data for classes. Okay, so he didn't give much information. He said map, string, class. I'm not sure what he means here. So my suspicion is if we have a class, then this class can have multiple functions, right? And can have multiple parents, all right? So how would we lay out the data? Let's open here a new document. Okay, so we have a struct which is a class info, yeah. And then I would have like a symbol. Okay. And then we would probably have something like so struct class info. Let me think. So class. Yeah, it's a good question. How do we... So a class essentially links to another class, and how should it be part... How should it link to something of its own kind? So we have std vector class info, right? Class info. Classes. Right? Okay, so and some of these classes, well, let's say, so let's also say we have std vector function info functions, and then let's do std vector size t, well, let's say index type, function IDs. And this is std string symbol. Okay, so this would be like a minimum information for a class without inheritance yet. How do we... Yeah, what we can do is std vector index type parent class IDs. Yeah, like this. So basically, if we first have to lay out all the classes, let's do also struct function info std string symbol, or let's call it name. Yeah. Okay, so let's think this through. So function, we have function info, which is in here, just the functions is vector. Then we have vector of classes. Right, it's just these classes in here, they have a name, and then they have inside a vector of function IDs. Yeah, so they link to some functions in here, right, that they own. And then they also have some parent class IDs with index. So that also refers to this guy here. Yeah. So we have flat vector of classes, flat vector of function info. Yeah, I think this. Yeah, I think this would work. Here's my suggestion: how to build class hierarchy relationships. First, populate all classes in. First, populate all classes. Then, afterwards, fill the. First, populate all classes and functions. Then afterwards, build links from classes, from class info to parent classes and functions. Member functions. I don't quite understand the question from Thompson's. What do you mean by two PDBs? What do you mean by two PDBs? You mean PDBs on both sides? Thyme.exe and game.dat? Yeah, I mean, if we would have PDB for game that would be a gold mine, I would say. Okay, I hope that answers this question. Good. Okay, let's get back to unassemblize tool. Good. All right. So, I mean, all the comparing currently works is for what we have in our simplified instruction. I had one more thought, and that was like, do we really need the ASM label? Do we really need this thing? Because because I need to think a bit. The I mean the I don't know. I guess it's okay. It's kind of weird that I just have it on one side. Well, if it's mismatching, then there is an empty... If these labels are mismatching on the sides, then there would be no label on one side and a label on the other side, right? Which I guess is fine. Yeah, I don't know. I mean, because technically, if we would link here to ASM instruction EX, then technically it would also work. Like there's a label inside, and if the label is not empty, it has a label. So I don't know. I can't really decide. Okay. Yeah, so we need to think about how do we deal with a situation when we have a shifted match. So let's say, let's try to visualize it. Let's scroll here a little bit to get some nice function. Yeah. Like, let's try to find some here. That one looks good, right? Well, let's take this guy. Yeah. And oof. Yeah, let's take a two notepads. Okay, so we have two notepads here, yeah? And we take this thing and we copy it on both sides. Like so, yeah? We make it extra dense. Okay, so we have this on both sides. But now let's say here's some error, yeah? And it does... I don't know, what could it do here? Fmul here, Fmul, it multiplies not just once, but it was another thing as well, right? So now this thing and this thing is pretty much identical, except there is this one line that is extra here, right? So it would be great if our comparison effort would show that these lines are identical to these lines, and all these lines are identical to, well, all these are identical to these, right? And here on this side is just this one is extra, right? So that would be the goal. But how do we do this cleverly? Whew. So what we can do is we can say if there is a mismatch, so we have the freedom to not count on either side, right? So we have the freedom to say, hey, we have a mismatch now. Don't count this guy, the side upward. Don't count this up to the next instruction. So we are at this instruction and at this instruction, right? They are mismatching. Now we could have the choice to say, don't count this upwards, just count this upwards. But how does he know which one to count upwards? He can only like test it. Oof. Huh. Well, we can only we can only guess, really, right? We can say, okay, let's look forward a bunch of lines and see if we get a match if we look forward. Then we have to do it on both sides because we don't know which one is wrong, right? Could be either side. So we could... Oof. Instruction. Empty instruction. We need a good idea first before we start trying to implement it. So, okay, so we need to do something here when we have the mismatch, right? When we have the mismatch, we need to... We would have to test forward if something... If one of these things would match again on another line, yeah, we could say, okay, but if there is none, I think there is a way, but I have not yet built the logic for it in my mind. But I can feel it's there. Yeah. It must be. I mean, it must be possible because other tools do it as well. There are merge tools that can do it fairly okay. So it is possible, but how do we implement that? That's a question. Yeah. Okay. Okay. So when we're here, we can say, let's look forward, and we can loop forward. We can loop forward one of the sides, look ahead to future instructions or later instructions, and compare it with the current instruction on one of the sides, right? And then see if we get a match. And then we take the one with the earliest match. Yeah. So we look forward on both sides, and the side that has the earliest match, then that will be the side that is being incremented here. Yeah. Yeah. And if we have no match, then we increment both. Yeah. Yeah. Yeah, this sounds reasonable to me. So let's look at our example again. Now, if I can get my eye under control. Okay. So here we have a mismatch, right? These lines. That's not the same. Okay. So then we say, all right, let's compare this line against this line. Is it a match or not? It's not a match. Let's test the next line. Is that a match or not? It's not a match. And so on until the end. Ooh, but that's quite expensive, isn't it? Yeah, maybe we should do okay. We should do it. We take turns. So we lock in these guys. These two lines are locked in. These are the baselines. So first we compare this one against this one. Then we compare this one against this one. And since these are a match, this one is a winner. This side is a winner, so this one increments, and this one does not. And if, let's say, these were different, then it would compare this one against this one, next step. And then the same again with this one against this one, and so on. Always take turns. And then we could time it out at a certain distance. Like, let's say we only look forward up to 10 lines, and then we stop it, right? We can put a limit. That's a good idea, I think. Yeah. It's simple enough. Yeah. I can't think anything wrong with it. Sounds like simple enough. It sounds efficient. it's taking turns, so it will find the fastest match, right? So in this case, it would be one or two turns, right? So yeah, this makes sense. This makes sense to me. Okay. Then let's implement this. Good. Okay, so we have we do it in here, of course. Okay, so yes. Okay, so let's put a comment here. Check if there is a shifted match coming up. Okay, so let's put a const expr size t. Do we use size t here for this? Yeah, size t. Let's put a limit. Let's call this look ahead limit. That's leak, not look ahead limit. Let's say, how many lines do we want? 10 maybe? Yeah, let's go with 10 for now. Yeah, 10, 16, 15, something like that. Good, so we say, here. Yeah. Compare, yes, and text. Yeah, this one is okay, so we will call this multiple times, so up to 20 times with a look ahead limit of 10. And then has to do with this every time. Instruction text array. This is quite a bit expensive. What is in here? Sizable array. Yeah. It's quite big, isn't it? 448 bytes. Oof. Text, yeah. I think Yeah, I'm already thinking about one step ahead, like performance. I thought about this algorithm and now already thinking about next step. Okay, what about the performance implication? So because what happens here is we do this, like if we would just like go from top to bottom once every instruction, then this is totally fine, right? Because we enter here, we split the instruction text, build these arrays, and then we compare them, right? But the problem is if we do this look ahead, right? Then we do this here, the look ahead, and then we split the instruction text. And we do this, how often? Let me think, 20 times, right? Yeah. 2 times 10. 20 times. So we do this here 20 times in the worst case, right? And then afterwards, we keep on going. So this is done, the mismatch instruction is done, we keep on going to the next, and then maybe it's again mismatching, and then again we look ahead up to 10, and then again it will be 20 times this, right? So it grows, like it does a lot of these things, and it does it again all over again on the same texts, right? So it keeps repeating, because like if we go here on the next line, so after this is done, we go on the next line, and then it does it here again, and then eventually it does it here again, and it does it again and again and again, every time. So it's 20 times 20, let's say. So let's say that, let's make an example. So let's say you have a let's say you have a function with 50 assembler instructions, yeah, 50, and all of them will be mismatching, yeah. So worst case, super mismatchy, yeah. So that means 50 times 50 times 2, just for the regular flow, right? So 50 times 2, this will be our the base, the minimum count to call the split instruction text. But now there will be more, because we have to do 100 plus, so it would be 10 times 2, again for 2 sides. Yeah. And that 10 times 2 times 50, right? Because you do it 50 times, like for each instruction you go times 50, if my math is mathing. So that's 1100. So we ballooned from 100 to 1100. So yeah, 10 times more. Just 10 times. Just 10. Yeah, 10 times. 10 times. No, there's something wrong in my math. It should be 10 times 2 times 2 times 50. So it should be, so this was 10, this is 1000. So it should be, it's 2100. 2100. So 100 plus 10 times 2 times 2 times 50, 2100, up from 100. So 2000 more. 2000 times this. That is too much. It's too much. So you see, like this gets, I mean, the function, like, let's see how expensive. Yeah, it is. It does some work. So it will have cost. It will have cost. If you do it like thousands of times, yeah, and then you have like hundreds of functions. So you can see, like, now let's say we have 2100. So on average, let's say a function has 50 lines, and then you have, I don't know, you have 100,000 functions. So that's 210 million times. In the worst case, that would be called here the split instruction text. And that would probably take a long time to calculate. So we can do this better. We pre-compute this once. We pre-compute this. Okay. Instructions. Instruction text array. Okay, let's using instruction text array vector. Array vector. So it's a SCD vector of instruction text array. Okay. So that means so empty instruction. So let's create a static instruction text array as empty instruction text array. Okay. Instruction text. Instruction text. Actually, I think this one can be local to the function. It doesn't have to be here. Let's put here const empty instruction text array. Okay, let's put it here. Okay, so what we need to do, well, let's put it here. And then we need instruction text array vector. Then we say instruction arrays 0. And then we have something build or create instruction text arrays, and in there we pass this here. Okay. And then we do the same for 1. Yeah. Okay, so this would then build us these instruction arrays. Yeah. And then here we do the same as this here. So instruction array 0, 1, count instruction arrays. And then we do empty instruction text array. So this will be this. Yeah. And so we need a new function here with instruction text array. How did we call it in here? Hold on. Array 0. Okay, so we call this array 0. Here array 1. Okay. And then here we create a new function here. So it will be static compare ASM. Why is this complaining? Because of that. Okay, and then we take these guys here and we put it in here. And then we do return compare ASM. We don't really need this function, but we can keep it for reference, I guess. Simple enough. We can also make it const. Yeah, and then we remove this. Okay, so basically we can now call this function with the broken down instruction text array or with the ASM text here. Yeah. Okay, that's cool. Good. So what this allows us to do now is here, since we have these instruction arrays, we can now, what do we do with this guy? Instruction 0, checks the label, yeah. So here we also, oh, we already have this here. What is the problem here? No, it's that. Right. No, I don't understand. What's the problem here? Maybe because this is not implemented yet. Let's implement this guy here. So we need a function static instruction text array vector. Create instruction text arrays. Yeah, and in there we pass. What did we pass? This, yeah. Instructions. So we create a new function here, and we do ASM match instruction array vector v, return v, and then we simply do ASM instruction x for this instruction const instructions and hold on, let's do v dot resize. Let's do const size t size equals instructions dot size v resize size for size t I equals 0, I smaller than size plus plus I, and then vi equals split instruction text from instructions I dot text. Yeah. Create instruction text arrays. Yeah, and that will be, maybe give it a better name. Arrays. Okay. Maybe we should call this split instruction texts, since we already have this established here. Texts. Then maybe we should move it down here to this one here. Yeah, let's see. So split instruction text. So basically this means we just need to do it for every instruction just once, right? And then we have it. So no longer thousands of repetitions. Good, that's good. So we have it, and it's in a vector, so it's not on the stack, it's actually on the heap. So it's also okay for the runtime. And yeah, we still have a compiler here. No suitable user-defined conversion. Instruction text array to text array vector text array. Right. There we go. Instruction text array. Instruction text arrays. Let's call this array instruction array. Yeah. Cool. Okay. And then we need to pass down here instruction. I realize also that there is a problem here. So let's say if it, I think we should run this comparison always. So that even if, like, let's say we have a jump and the jump is mismatching, that we still get like a comparison. Because right now it wouldn't even compare, and then it wouldn't show any instruction mismatch bits. Yeah, we should probably run this always. Yeah, so we just put it here. And we just put it here. Yeah, I think that makes sense. Yeah. Okay, and here instead of instruction text, we now pass instruction array 0 and instruction array 1. Yeah. Okay, so we got that covered. So that optimizes the code for what we want to do with our look ahead now. Yeah. Okay, so we got that already settled. That's good. When you program, you have to think about these things. You have to think about the complexity. And this certainly here was a avoidable complexity. Now, I'm not sure like how expensive this thing in practice is. It's probably very fast because yeah, it just makes one pass over the string. So it's not awfully slow. It will be fast, but still, this thing adds up. If you do it millions of times, there will be some cost, right? And that cost can be seconds or minutes, right? So you better be smart. Yeah. Oh, good. Okay, now I forgot what we wanted to actually do. We wanted to look ahead. Okay, so what we need is a second pair of indices. So let's put it k0, k1. Okay, so we need to count again here. Sorry. Okay. We should probably say I0 plus K0, I1 plus K1. I think and only if both are smaller. Yeah. And then we also need to get instruction. No. instruction array. We don't need this check here. I think. Oof, this is getting complicated here. Okay, so I think we need K0 and here K1. K0, K1. Oof. Okay, I think we can. So we can already count. We start with one side up. Yeah, let's start with the left side up. 1. And here at the end we do plus plus. Well, we do if K0 larger than if K0 larger than K1, then plus plus K1, else plus plus K2 K0, right? So they always increment in they always increment in turns. And if can make another condition here, and K1 smaller than 10. Right? So if K1 hits 10, then we are over our look ahead limits, definitely, right? Mm-hmm. Let's put this here. Okay, so our basics, right? Okay. Okay, and in here, so we now have, so basically, hold on, we always compare right. Instruction. Okay, let's call this instruction array. look ahead instruction array. Is that fair? Look ahead instruction array. I just realized that I'm violating our naming styles. Look ahead instruction array. Look ahead instruction array. Okay. Empty instruction array. Instruction array. The naming here is a little bit ambiguous. We have instructions and instruction arrays. Sounds very similar, but okay. Good. So look ahead instruction array 0 and 1. So we need to. So if K0 is bigger than K1, it means we are now looking ahead on 0, right? So we move this guy in here, and the other one we move in here. Then we need to put here the brackets. Good. So I0 plus K0. So in this case, it would be I0 plus 1 on the first iteration. And then it does K1 plus plus. So on the next time, K1 will be 1 and K0 will be 1. So it will enter this branch here. And then it will do it for the other side. Yeah. Okay, so now we need to compare. We need here mismatch detail. Let's call this look ahead mismatch detail. Maybe we just shorten it to look ahead detail. So we can also make it const. So look ahead detail. If detail instruction mismatch bits are not 0, if they're not 0, then what? Then Wait, so here it needs to compare instruction look ahead array with instruction array 1. Yeah. And if it has that, so if it is not mismatching, then we know, let's copy the same here before I start thinking. So this is 1 and here instruction array 0. Yeah. Good. So if the future instruction, if the look ahead instruction is not mismatching, it means we have a shifted match. Here, a shifted match. Right, so let's look at this. So in this case, our look ahead is this, right? We look ahead 1 and we compare these and they are the match. So there's an instruction match. So this one wins here. Okay, then what do? It wins. Now what? I think we need to increment the ice here at this point. Shit. So there is a instruction mismatch bits. Hold on. It should be 0. I should compare to 0. Yeah. I should compare to 0. So if there is no, so this means there's no mismatch. Yeah. There's no mismatch. Instruction mismatch bits. Maybe on our look ahead detail, maybe we can make it a little bit more readable by adding helper functions. Bool mismatch detail is matching const return instruction mismatch bits equals 0 and is mismatching not 0. Yeah, a little helper. So then we can say, hold on, I have violated the naming conventions again. Is mismatching. So if is matching, that's what we want to say, is matching. Okay, so if it is matching, then we say, so okay. There's more to consider here. So let's say we have multiple lines. Let's look at our example again. So let's say, let's just copy this here, yeah, and let's say there's a C and so on. Let's make another here. Oops. It's times 1, 0. Okay, so let's say we have this. Then, so this would match this, but then we know already that there will be 1, 2, 3 lines in between. So we can already use this information to also to fill the further ASM mismatch lines, right? Oof. How do we do that? Okay, we are on the right track, but it's getting a little bit more complicated. Okay, so it's there. You just need to think carefully. Okay, so let's look at our example once more. So we go forward and we hit that thing. 1, 2, 3. Good. So basically here we know the 3 from one of these. Here, K1 will be 3. Wait. So K1 is 0 here at this point, right? Yeah, so yeah, K1 is 0 here. 1, 2, 3. 3. And then there is a match. Okay. So at 3. Yeah. 3 is a match. Just need to get the brain working. So we look ahead. Look ahead detail is matching. Good. So we know at this point K1 must be 3, right? So K1 is 3. So that means I can do here. K1 is 3. So we would push. Yeah. I think I have the idea. So we say for size t, k equals 0, k smaller than k1 plus k, and then we create ASM mismatch. What is in this mismatch? Yeah, let's do here. STD move. STD move. Don't think it really makes a difference, but. Okay, so here we say ASM mismatch, and we put instruction pair to so we put it on the empty instruction, 0 on empty instruction. Hold on. So K0 is left side, K1 right side. So what? Oh, hold on. So look ahead is wrong side. This must be 0. Right, and empty instruction goes here, and here is instructions 0, I0 plus k, right? And then mismatch, look ahead detail. Let's not cut corners here on our naming. Okay, look ahead mismatch detail. Okay. Okay. And we do the same here, but for K1. K1, and here we do 0, 1, empty instruction, and I1 plus K. I think this is correct. Now we have a lot of code duplication, so to say. Okay, we would also need to break out of this here. Break. No, hold on. The break would be afterwards here. Is matching, yeah. Break would be here. Right. Okay, but if it's broken out, then so this break breaks out of this loop, and basically, what about I? This one. Ah, right. So I0, oh, I'm so confused. I need to verify. So we need to have something like I0 plus equals K0. But I need to verify that it's actually like the correct place. I'm a bit confused right now. Okay, so left side is bigger than right side. Left side is bigger than right side. So that's why we compare left side, look ahead left with base right side. And here the other way around. Base left with look ahead right side. Okay. And if there is a match with look ahead right side, then we add ASM mismatch records with empty instruction on the left side, but instructions on the right side. And this is wrong here. I1, no, it's correct. I1 plus K. And here is I0 plus K. Yeah, okay, so I think this is correct. Okay, and then once the placing is done, then by the way. We should probably reserve a little bit here. Let's do result lines dot reserve count 0 std max count 0 count 1 and then multiply it a bit because of the labels times E. Well, const size t estimated counts double times 1.2 maybe. Static cost. Oh, I make a C cast size T. Yeah. Double. Double std max times 1.2. Yes, I think that's generous. Reserve estimated count. Yeah. Okay, back to this. Okay, so once this is done, okay, so here, maybe we add some comments here. Right side. Right side has right side is right side is look ahead, right side is matching with base left side. Yeah. Look ahead, left side is matching with base right side. All right? No. Got it wrong. Look ahead. No, it's correct. This is a base. Left side is matching with base right side. Yeah, it's correct. Okay. And so so here we push on the left side, so we need to K0, K0, okay. Look ahead, right side is matching with base left side. Look ahead, right side. It's wrong. Hold on. This is wrong. Why is my description wrong? I think this should be here, and this should be here, no? Look ahead, left side. Yeah, this is look ahead, left is matching with base right side. Yeah, this is correct now. Look ahead, right side is matching with base left side. Why am I confused all the time? Unbelievable. Okay, and now I think the description matches the actual logic. Good, and so now we need to sort out this one. So if left side is matching, look ahead, left side is matching base right side. So here we add those instructions. And then we count, so this is also wrong. So here we need to count this. And here we need to do this. All right, so because we took those instructions from the left side, so we need to increment this side as well, and here this side. Yeah. I1 plus K1. Okay. I think this is now correct. Oof, it's quite complicated. Okay, but now we still have one thing to do. So basically, if one of these conditions is hit here, then this doesn't need to happen, right? So we need something like a bool has look ahead match false, and then we say has look ahead match equals true, and the same here. I wonder if we can also determine this implicitly from these. Okay, 0. I don't think so. Well, only if both are 10. Well, no, it could time out before already. No, I think this is robust, yeah. Okay, and then we say if it didn't have a look ahead match, then we append this here. Right. Oof. Okay, I said this is quite complicated here. Oh, hold on, we still have a problem here. Oof. Okay. I think there is more. Okay, so let's do a condition here. Oops. If not is matching, and we can say if is matching or has look ahead match, else this. Because if we do this look ahead, then we know hold on, instruction 0. Yeah. Okay, so here I think we need to pick instruction I1 plus K1. Let's put these outside. Let's put them on 0. Plus plus k0. I think here's a mistake. Because no, it doesn't. It's not. This is correct. Good. K0. So basically, if yeah, so I0 plus K0. And the same here. 0. Yeah, because basically, what if it has a if it has the look ahead match, we already know at this point that we have a match, right, at this position that we already determined. That's why we can say if is matching or has this look ahead match, then we have a match here to push back. Otherwise, if it has neither of these things, it will be a mismatch, right? And then here at the end, we can happily increment both of these. I think this is correct. But it's possible I made a mistake, but logically, it's sound to me. It makes sense. Maybe we can make it a little bit more readable. This down here is not perfectly readable. We have instruction. Okay, this is illegal what we're doing here right now. This is illegal. Or is it? It is illegal. Yeah, I think this is already illegal what we're doing here, because this can already be empty instruction here. Like it can I0 can already be smaller than count 0. No, it cannot be here. No, not here. Not here. But here. This is illegal. Yeah. Instructions. Okay, but this is also wrong because this would need to be here. And then we can simplify this to is matching equals true. Then we don't need this one. So basically it enters is not matching, and then it can set itself again to is matching. Yeah. And then it can enter here. Okay, but this would still crash. Yeah, I need to be very careful here. So I think we need another of these here. Is matching true. Mismatch detail. This one I can put here. Then we put this here. If I okay. Oh. I hope that this is correct. Oh, but there's a mistake here. Still, because now we lose labels. We lose labels. So here we would have to say if instructions I0 plus k dot label, if not label dot empty, ASM label. Oh boy. Maybe we should simplify this to instruction 0. Instruction 0. Instruction. Oh man. Remove this. Instruction 0 I plus k. So we just need to do this once, and then we use here instruction 0. And here as well. And here we use we need an empty label or empty string, std string, empty string. Oh boy. Here's a match empty string. Okay, so here we need to say as empty string. Right. Oh boy. Okay, let's put the same here. Because otherwise we would lose labels here. Instruction 1, instruction 1, I1 plus k. So here we put empty string here, instruction 1 dot label, instruction 1 dot label, asm label. Yeah, okay, this should be correct. Well, it's getting quite complicated here, this code. Look at left side. Yeah, okay, so okay, I think that this is correct now. Let's go through this once more. So we have instruction array. This one is set in stone here. And we then do one simple compare to begin with. Then we know whether or not it's mismatching. Then we just look at this instruction and we check if there's label. If there is, then we place back that. And if there is an instruction that is invalid, if is invalid, is matching for there. Let's jump. I do actually want to, if is invalid, what does it mean for our text? Oh, it's fine, yeah. Okay. Okay, so is invalid false. Yeah, I assume that this is correct. Good, so K0, K1, both set to 0. Okay. Is mismatching false? If not, is matching. Yeah, so this is correct. Check if there's a shifted match coming up. Look ahead limit 10. K0. Now the question is this limit, is this reasonable? 10. I guess we could raise it, 20 maybe. It's kind of artificial, right? I don't know. Look ahead limit is artificial. Well, I don't know how to describe it. Look ahead limit. Okay, let's go with 20 for now. So quite a lot of instructions. Okay, so while I plus K0 is smaller than the count 0 and I1 plus I2 is smaller than count 1, have a look ahead limits. Have a look ahead, yeah. So if left side is bigger than right side, the index, then we look at I0 plus K0. Then we compare the ASM text. Then we check if it's matching. If it is matching, then we go through the number of lines and we check let's add a comment here. First, the look ahead takes turns on both sides. Look ahead takes turns on both sides. The first winner will first look ahead match will determine the first look ahead match will determine the look ahead takes turns on both sides. The first look ahead match will the first look ahead match will Look ahead takes turns on both sides. The first look ahead match will determine the side that skips ahead. Yeah. The first look ahead match will determine the side that skips ahead. Yeah, I hope that describes it sufficiently. Okay, what's the time, by the way? Oh, 2 hours. First look ahead match will determine the side that skips ahead. Okay. Okay, how about we take a break now? I'm fairly confident that this is correct, but I could be wrong. Maybe there is some logical mistake, but we will see this once we debug through a sample. If we have a sample, hopefully we do. And then we can see like if it actually works correctly. There could be some mistake. It's easy here to make mistakes because it's quite complex. But if we are lucky, it's correct. Yeah. I wonder if we should like put it into a function. Because I mean it's like it's doing the same just on one side or the other. I don't know. Maybe it's fine. Let's see if it compiles. Oh, recursive. Oh, I see. Array. There we go. Okay, so it compiles, no errors, no warnings. Yeah, let's test this on the next session. I will take a break now and then I will be back. Yeah. All right. I hope you enjoyed it. Wish you a great day or night. Until next time. Goodbye.